Think about the early internet. Remember that. A bunch of separate systems that couldn't easily connect until standards like HTTP and SMTP came along.
Right, it was fragmented.
Exactly. And that's kind of the moment we're in with AI agents right now. We've got all this incredible potential, but these agents often operate, in isolation.
Little islands of intelligence.
Precisely. So for this deep dive, we're tackling the big question. How do we move from these isolated islands of AI to a connected continent?
A unified ecosystem.
Yes, our mission is to explore the emerging solutions that aim to create a more interconnected and efficient ecosystem for AI agents. We'll be unpacking the different approaches, things like Google's Agent-to-Agent or A2A.
And Anthropic's Model Context Protocol, MCP.
Right, and then zooming out to the AGNTCY collectives, a pretty grand vision for an internet of agents.
The big picture they're painting.
Definitely. So let's see how these pieces of the puzzle fit together.
Okay.
And maybe let's start by unpacking how these agents might actually, talk to each other.
Sounds good. Let's dive straight into Google's Agent-to-Agent, A2A. Now, what's key here, I think, is that Google isn't trying to dictate how you build an agent.
Okay.
Instead, they're tackling the fundamental problem of communication. Think of it as establishing a universal language.
Like HTTP for the web.
Exactly like HTTP. It allows any web browser to talk to any web server. A2A aims to let any AI agent, regardless of where it came from, connect and interact.
Right, finding that common ground. And a central part of A2A is something called the agent card. Is that right? It sounds almost like an AI's profile page.
That's a great way to put it. The agent card is basically a JSON file that an agent hosts, usually at .wellknownagent.json.
Ah, the standard well-known location.
Yeah, familiar territory for web folks. The core insight is that this card allows an agent to broadcast, hey, here's what I can do and how you can ask me.
Okay.
It details things like the agent's name, like Cyber Threat Intelligence Agent. In one example, its description, URL, version, who the provider is, standard stuff.
But it gets more specific, right?
Oh, yeah. Where it gets really interesting is the capabilities section. Like, does it support streaming, for live updates, or push notifications?
Oh, okay.
And crucially, it specifies the authentication methods it understands. Think bearer tokens or AP keys, so other agents know how to securely connect.
And the real substance, it seems, is in the skills section of this agent card.
Precisely. The skills array lists the specific tasks the agent can actually perform. Each skill have an ID, a human-readable name and description, maybe some tags for easier discovery.
And you mentioned an example.
Yeah, the source had that Cyber Threat Intelligence Agent with a skill called threat detection, and it even gives an example in invocation like analyze these firewall logs for suspicious activity.
So it's very clear. It gives other agents a really structured way to understand and use this agent's abilities.
Exactly. No guesswork.
So, okay, once these agents have found each other using these agent cards, how do they actually, swap information and get work done?
A2A uses JSON RPC for the actual task exchange.
Okay, JSON RPC.
Yeah, think of it as just a standardized way for computers to make requests and get answers over a network. Simple, well understood. It ensures the interactions are structured, predictable.
And what about longer tasks? Does it just wait?
Good question. No, for longer tasks, A2A supports server-sent events, or SSE.
SSE, right.
This lets the requesting agent get continuous updates while a task is running like a live progress bar instead of just sitting there waiting for the final result.
That makes sense. More interactive.
Yeah, and it's not just limited to plain text either.
Yeah.
A2A is designed to handle various forms of data, like files, structured information, even forms.
Okay, pretty flexible. And it sounds like security is built in from the start, using standard web stuff.
That's the idea.
Yeah.
Standard web practices like HTTPS for encryption, and those authentication methods we mentioned are detailed right in the agent card.
Right.
So yeah, A2A is clearly focused on the communication aspect, how agents talk.
Got it. Okay, let's switch gears then. Let's talk about Anthropic's Model Context Protocol, or MCP. It often gets called the USB-C for AI. What's the core idea there?
All right, the USB-C for AI. If A2A is about how agents talk, MCP is more focused on how AI models and agents act.
Act? How so?
Specifically, how they interact with external tools and data sources. The USB-C analogy really highlights the goal: create a standardized way for AI to plug into different capabilities.
Avoiding that nightmare of custom integrations for every single tool or data source.
Exactly. The M times N integration problem, MCP aims to solve that mess.
Okay, so how does this USB-C actually function in the AI world? What's the structure look like?
MCP uses a client-host-server architecture.
Client-host server.
So the host is the main AI application you're interacting with. Could be Claude Desktop, maybe an AI-powered IDE, something like that.
The thing managing the whole process.
Right. The host manages everything, and it creates these lightweight client instances. Each client basically has a dedicated one-to-one connection to an MCP server.
And the servers.
These servers are independent processes. They're the ones that expose specific functionalities like accessing data, using tools, maybe providing reusable prompts, and they all do it according to the MCP standard.
So the main AI app, the host, uses these clients as sort of intermediaries to connect with different servers offering specialized abilities. Is that right?
You got it. And the MCP standard defines three main ways these servers can expose their capabilities.
Okay, what are they?
First, there are tools. These are basically executable functions, think making API calls, running database queries, that kind of thing.
Right, actions.
Second, resources. These are more like read-only streams of contextual data. Could be files, logs, API responses, stuff the AI needs to know about.
Contextual info, got it.
And finally, there are prompts. These are reusable, templated instructions that you can combine with the tools and resources.
Interesting. So tools, resources, and prompts. And how do these components talk to each other? Is it similar to A2A with web standards?
It can be. For local processes, communication often just happens over standard input-output stadio. Nice and simple.
Okay.
But for network services, yeah, MCP uses HTTP with server-sent events, SSE, much like A2A.
Okay, so some overlap there in the transport. Now, you mentioned the host manages things. Security must be a big piece of MCP, right? How does that work?
It is, and it relies heavily on the host application, which makes sense. As you said, that's the user's main interaction point.
So what are the key security ideas for MCP?
Well, several key principles are paramount. User consent is huge. The host is responsible for getting explicit user permission before an AI goes off and accesses resources or uses tools via an MCP server.
Makes sense. User needs to be in control.
Absolutely. The host also manages the connections, permissions, the whole lifecycle of the clients. It acts as the central authority for security enforcement.
Okay.
There's also this local first principle. Often servers run locally by default to keep sensitive data close, unless the user explicitly authorizes remote access.
Smart. Keep it local unless needed.
And then you have the standard stuff. Transport security like TLS for remote connections, obviously. Input validation on both client and server sides, critical to prevent malicious attacks.
Standard hygiene.
And finally, access control. Things like role-based access control, RBAC, or access control lists, ACLs, usually implemented within the host or maybe the server logic itself to manage permissions finally.
It sounds like the security model places a lot of trust and responsibility on that host application.
It really does.
So what are some of the potential security risks you need to be aware of with MCP?
Good point. The sources definitely highlight risks. Like granting excessive permissions to servers is a big one. It underscores why that principle of least privilege, only giving the absolute necessary permissions, is so vital.
Right. Don't give it the keys to the kingdom if it just needs to open one door.
Exactly. Other potential issues include the risk of OAuth token theft, if that's how a server authenticates itself, or what happens if a server itself gets compromised. It could gain unintended access.
Yeah, that's worrying.
So mitigation strategies include things like using short-lived tokens, carefully monitoring prompts to prevent injection attacks, isolating infrastructure where possible, basic security diligence, but it applied to this new context.
Okay, that gives us a good picture of A2A and MCP. Now let's shift focus again to that third initiative, AGNTCY, and their vision for an internet of agents. This sounds, well, bigger.
It definitely feels broader in scope. AGNTCY, and yeah, you pronounce it agency, is presented as this open source collective. You mentioned Cisco, LangChain involved.
Right, some heavy hitters.
And they're not just focusing on communication like A2A or tool use like MCP. They seem to be aiming to build a complete foundational infrastructure for this whole Internet of Agents idea.
Drawing parallels to the core internet protocols.
Exactly. What's striking about AGNTCY is it's not just one protocol. It's more like a suite of interconnected standards, protocols, and even reference implementations to use.
Covering the whole life cycle.
That seems to be the goal. It's designed to address the entire life cycle of these agentic applications.
Okay, and they've broken this vision down into several core components. Let's maybe walk through them. First up, the Agent Connect Protocol, ACP. What's its job?
Okay, ACP Think of ACP as the standard front door for interacting with any agent built using the AGNTCY framework.
The interface.
Precisely. It defines standard, kind of REST-like web endpoints for a whole range of operations. You can configure an agent, invoke it either synchronously, you wait for the answer, or asynchronously, you fire it off.
Okay.
You could retrieve its output, including getting live streams of data back. You can handle interruptions, like if the agent needs more info from you. And it even lets you manage stateful conversations using this concept of threads.
Threads, interesting.
Yeah, so the goal is to standardize how you interact with any AGNTCY compliant agent, no matter what it does internally. They even provide a Python SDK to make it easier for developers.
Got it. So ACP is the interaction standard. Then there's the Agent Gateway Protocol, or AGP. What role does that play? Is that different?
It is different. AGP is the underlying network transport layer. It's the plumbing that makes those ACP interactions happen securely and efficiently across the network.
Ah, the low-level stuff.
Exactly. It's built on gRPC, which uses things like HTTP2 and protocol buffers for speed and reliability.
Okay.
And AGP supports more than just simple request response. It can handle one-way streaming, two-way streaming, publish-subscribe patterns.
Pub-sub, so an agent can broadcast info.
Right. Broadcast to many other interested agents, and even fire and forget messaging where you don't need a reply. So AGP is really about the reliable and efficient movement of messages between agents.
And to help with that movement, they have the agent gateway itself, like a physical piece.
A logical piece of infrastructure, yeah. The agent gateway acts like a smart router and a security checkpoint for agent communications within this AGTCY world.
Okay.
It handles the secure routing of messages, forwards data and control signals between agents. It manages those pub-sub interactions we just mentioned, and it can potentially enforce security policies too. Think of it like a central hub managing the traffic.
It's really starting to sound like a dedicated network just for AI agents. And they also mention an Open Agentic Schema Framework, OASF. What's that about? Schema suggests description.
You nailed it. OASF is all about standardized metadata. It's a consistent way to describe agents.
What kind of description?
What their capabilities are, what other agents or services they depend on, maybe performance metrics, things like that. Having this standardized description is crucial for agents to discover each other and for managing the whole ecosystem.
Which leads perfectly to the next bit, the agent directory. That sounds like a phone book for these agents.
That's a perfect analogy, yeah. The agent directory is envisioned as a distributed service, kind of like DNS for the internet. Agents can register themselves using their OASF-compliant descriptions, their manifests, and then other agents can find them based on the capabilities they advertise.
Makes sense. Discovery is key. And finally, they have the agent workflow server.
Yeah, this is more of a reference implementation. It's a way to actually deploy and run complex workflows that might involve multiple agents collaborating.
Okay.
And importantly, it exposes these complex workflows through that Agent Connect protocol, ACP. So another agent or application can interact with the entire multi-agent workflow as if it were just a single unit.
Wow, okay. That's really comprehensive. It covers discovery, communication, transport, description, execution. And with such a complex system, security must be like front and center for AGNTCY.
Absolutely. The sources really emphasize that security is a foundational pillar for AGNTCY. It's not an afterthought. It's built in with a multi-layered approach right into the infrastructure.
How so? What are some examples?
Well, for instance, that Agent Gateway Protocol, AGP, is designed from the ground up with end-to-end encryption. It includes authentication, verifying who the agent is, and authorization controlling what they're allowed to do.
And they're looking ahead, too.
Yeah, they're even looking at advanced security measures like messaging layer security, MLS, and potentially quantum-safe cryptography down the line.
Wow, future-proofing.
And ACP, the connection protocol, also requires agents to authenticate incoming calls and declare which authentication methods they support, similar to A2A's agent card.
Okay. What about identifying agents?
There are plans for a decentralized system to manage and verify agent identities, perhaps using DIDs or something similar. And they're also working on a dedicated agent security framework specifically to address the unique risks that arise when you have multiple agents collaborating in complex ways.
It really sounds like they're trying to bake security into the very fabric of this potential internet of agents. They even have a practical getting started tutorial, right? Something about a marketing campaign manager. What does that show?
Yeah, that tutorial really helps make the whole AGNTCY vision more tangible. It shows how you can use their LangGraph framework, which is part of the ecosystem, along with ACP, to build a distributed system.
With multiple agents.
Exactly. It has different specialized agents, like one that writes email copy the mail composer and another that reviews it, the email reviewer, all working together on a marketing campaign.
Okay.
It really highlights how ACP enables communication between these separate agents, how the overall state of the campaign is managed across them, and how data flows. It even uses an intelligent I/O mapper.
What's that?
It's another agent, basically, powered by a language model that handles transforming data between the different steps or agents.
Clever.
Yeah, and it shows connecting to external services like SendGrid for actually sending the email using something called an API bridge node.
So it covers the whole pipeline.
Pretty much. The tutorial walks you through creating the agent models from their descriptions, those OASF manifests, building the dynamic workflow logic, generating the final deployment manifests, and then actually deploying it all using their workflow server manager. It's a really concrete example of how these different AGNTCY pieces fit together to build sophisticated collaborative agent systems.
Okay, so it's clear that just having protocols for communication and tool use like A2A and MCP, while necessary, might not be sufficient on their own, especially when you think about large-scale, really intricate systems.
Exactly.
It brings back that earlier point you made, like a company where everyone can only DM each other, works for a small team maybe.
But it breaks down fast. It becomes unmanageable as you grow.
Yeah, and that seems to be where the underlying infrastructure becomes absolutely vital.
It really does. When you start considering managing communication, coordination among potentially hundreds, maybe thousands of AI agents inside an organization, just relying on direct point-to-point connections defined by protocols like A2A and MCP, well, it creates huge challenges.
Yeah. In terms of what? Scalability.
Scalability, definitely. Reliability, too. And just being able to monitor what on earth is actually happening. Observability becomes a nightmare.
Right. So this is where technologies like Apache Kafka and Apache Flink enter the picture. Can you give us a quick rundown? What are these and why are they relevant here?
Absolutely. So Apache Kafka, it's a distributed event streaming platform. Originally came out of LinkedIn, actually.
Right.
Think of it as a highly scalable, highly fault-tolerant message bus. A central nervous system, almost.
A message bus.
Yeah. It allows different systems agents, in our case, to publish streams of events like task completed or data received, and other systems can subscribe to those streams in real time.
Oh, okay. Publish and subscribe.
The key is that it decouples the systems producing the data from those consuming it. The producer doesn't need to know who's listening, and Kafka makes sure the data is durable, stored reliably, and can even be replayed if needed.
That replayability sounds useful for debugging or auditing.
Hugely valuable. Kafka is massively used across industries already. Finance, fraud detection, IoT data collection, you name it.
Okay, so Kafka is like the super reliable, scalable highway for messages. What about Apache Flink?
Right. If Kafka's the highway, Flink is maybe the smart traffic control and processing system on that highway. Flink, also open source, is a real-time stream processing engine.
Processing. Okay, different from just moving messages.
Exactly. It's designed to process massive volumes of data, event by event, with very low latency. And crucially, it can maintain state while it processes these continuous streams.
Maintain state.
Yeah, remember information from past events to make decisions about current ones. So while Kafka handles the reliable movement and storing of event streams, Flink is all about acting on those streams in real time, transforming data, enriching it, monitoring for patterns, orchestrating complex actions based on the flow of events.
Okay, Kafka moves the data streams. Flink processes them intelligently in real time. That's a clearer distinction.
You got it. If Kafka is the messenger, Flink is kind of the real-time brain analyzing and reacting to the messages.
So how do Kafka and Flink really complement A2A and MCP in building these, scalable agent ecosystems? What problems do they solve that the protocols alone don't?
Well, they directly address many of the limitations of just having direct agent-to-agent communication.
Right.
Take decoupling, which we mentioned with Kafka.
Right.
An agent finishes analyzing a report. Instead of needing to know exactly which other agents need that result and sending it directly, which gets complex fast, it just publishes a report analysis completed event to a Kafka topic.
And whoever needs it is listening to that topic.
Exactly. Any other agent or system interested just subscribes. That's crucial for handling large numbers of agents without creating a tangled mess of connections.
Makes sense. What else?
Kafka provides that built-in observability and replayability we touched on. Having a durable, time-ordered log of all agent events is incredibly valuable for tracking behavior, debugging complex interactions, and auditing what happened.
You can see the history.
Precisely. And Flink enables agents to react immediately to these event streams. They can filter events, combine information from multiple streams, detect complex patterns over time, and trigger actions based on dynamic conditions, all in real time.
So more sophisticated, faster reactions.
And Flink also brings robustness and scalability specifically for the processing logic. Flink jobs that run these long agent workflows can be scaled independently and can recover from failures automatically without losing their place or state. That's critical for important tasks.
Right, you need that resilience.
Ultimately, Kafka and Flink enable a much more event-driven style of coordination. Agents interact through these shared streams of information, rather than relying only on synchronous direct request response calls. It's just a more scalable and resilient pattern.
Okay, let me try to recap that. So A2A is focused on how agents speak to each other, the language. MCP is about how they act on the world using tools and data.
Right.
Then Kafka comes in as how their messages and events reliably flow through the system, the transport layer.
The flow, exactly.
And Flink provides the intelligence for how those flows are processed, analyzed, and acted upon in real time. The thinking layer on the flow.
That's a great way to summarize it. Speak, act, flow, think.
It really sounds like these four pieces or maybe concepts together could unlock a whole new level of capability for AI systems.
And that's precisely the argument the sources make. While protocols like A2A and MCP are essential, they provide those necessary standards for agent behavior. They probably aren't sufficient on their own if you want to build truly robust, enterprise-grade, interoperable AI agents.
You need more than just the language rules.
You need that underlying event-driven infrastructure, like Kafka provides, and you need the sophisticated, stateful, real-time processing capabilities that Flink brings to the table. That's what enables the necessary scale, reliability, observability, and flexibility.
And they proposed a layered view.
Yeah, they even suggest this kind of four-layer view for what they call the emerging new internet stack for AI agents.
Okay, what are the layers?
At the base, you have the protocols A2A, MCP. They define what agents can fundamentally do, their interaction primitives.
Layer 1.
Then layer 2. The frameworks for actually building agents, things like LangGraph, which AGNTCY uses, or Crew AI, Autogen, etc., they define how agents are constructed and operate.
Layer 2, how to build.
Layer 3. The messaging infrastructure Apache Kafka is the prime example here. It manages the flow of information between all these components.
Layer 3, flow.
And finally, layer 4. The real-time computation layer, Apache Flink being the key technology. This enables the thinking and action based on that information flow.
Layer 4, thinking on the flow. Protocols, frameworks, messaging, computation, what, how, flow, thinking.
That's the proposed stack.
Wow. It really does feel like we're at a potentially pivotal moment in software evolution, doesn't it?
It does.
Just like the original internet stack, TCP/IP, HTTP, DNS unlocked global connectivity for information. This emerging stack for AI agents seems poised to unlock a future where autonomous systems can actually collaborate, reason, and act together in incredibly powerful, complex ways.
That's really the core of it, I think.
Yeah.
A2A and MCP are giving us those vital protocols for communication and tool use. They're defining the standards.
Right.
But it's Kafka and Flink, or similar technologies, that are laying the essential infrastructural groundwork. They provide the coordination fabric, the observability, the resilience you absolutely need at scale.
And it's the combination that's powerful.
Exactly. It's that combination that has the potential to move us beyond, interesting but isolated agent demos towards truly robust, intelligent, production-ready ecosystems.
And ultimately, this isn't just about making individual AI agents smarter or more capable in isolation. It seems to be about enabling an entirely new paradigm of software.
How so?
Well, one where agents can seamlessly collaborate across different systems, maybe even across organizational boundaries, providing real-time insights, taking autonomous actions, leading to this idea of genuine distributed intelligence.
Yeah, intelligence that emerges from the interaction, not just residing in one place.
Exactly.
Indeed. So maybe the takeaway for you listening is the next time you encounter an AI agent, think beyond just its individual skills. Consider how it fits into the broader landscape.
Right. Can it talk to others effectively?
Can it coordinate its actions within a larger system? Can it understand and react to the flow of events around it? Can it adapt and evolve within that connected environment?
Because, as our sources seem to suggest, the future of AI isn't just about having agent-powered applications.
It's about building an agent-connected world,